Okay, guys, the homework check is on Monday. Is the sound? Okay. And we're gonna go over questions today on worksheet 22, particularly ones that are just really hard to read. This is the very top of the worksheet. I think even one of these was kind of hard to read. Number 5 was a little hard to read. Did you want me to do number 5 just so we can say we did it?
Yep.
What can both of these be rewritten as powers of? 3/4, yep. 9 and 16 are 3/4 what? 9/16 is 3/4. Let me try to speak proper English. Squared. And then there was a 3x minus 2 up there. And this side is just a 3/4. And a 5x plus 4. You'd be really, truly better off if you were doing this on another sheet of paper because there's not enough room. Okay, so I'm going to leave you guys to solve that. All right? Everything else on 1, 3, 5, and 7 seems like you could read it? Yep, this is an 18 that was a little hard to read right up there on number 3. It's an 18. All right, I am going to move to 9 and 10. I did 9 earlier with 4th period, and I did 9 by taking the log of both sides, and then I realized, I'm like, how in the world do they think this is example 1? Does anybody in here recognize how you could rewrite those both as the same power besides Mrs. Heimer? Yeah, try it. 1.5 squared, guys, is 2.25. So they thought you were going to recognize that this is equal to this. All right, so I think this was a really hard question. I did it 4th period. I didn't even pay any attention. I just did it by taking the log of both sides and dealing with really atrocious decimals throughout the whole process. And then I got all done. And I was like, example 1. And then I realized that they were both powers of the same thing. So I'll give you the hint. You can do it this way, but you could have definitely done it by setting them equal was the whole process because it says where are they the same number of people. Your answer is people, by the way. Thank you. No, it's which week. You're right. It's weeks. T equals weeks. Week whatever. Week number. Okay, you're right. Nope, it's my fault. Okay. I don't know. All right. Can we look at number 10 because this has got a weird part to this question. Who can tell me the continuous interest for putting $5,000 in at 3%? What would that look like?
5,000 e to the 0.0. Wait.
Yep, and then you'd need a t for how long you're going to leave it in there, okay? The second part, so the second account is annually compounded, okay? So that's going to be 1 plus 0.03 over 1. They're just doing it once a year, so you don't even need the 1. And to the 1 times t, or just t up here, you're putting in $5,000, but they're going to match 4,000. Now, I had a little bit of an issue with this question, or 4%, sorry. A little bit of an issue because they assumed that the bank just put the extra 4.4% in your account at the very beginning when I was keying it, and I was kind of like, really, would the bank do that? Just hand you the money and let you have the extra 4%? Maybe they would just take it back if you withdrew it within a certain amount of time or something. But what is 4% of $5,000, guys? Can you find that? Okay, it's $200. So they're giving you an extra $200 to put in your account. So this becomes $5,200. All right, so that's the answer to A right there, both of those. B says, how many years will it take for them to catch up with each other? I did this by graphing. I'm not too sure how you would solve that without, because you can't divide and get rid of those, so taking the log of both sides comes a little hairy. Let's just do it by graphing. Alright, so in y1 I put 5,000 times e to the 0.03x. And in y2 I put 5,200, and then I added this all together because I hate typing on this silly thing, and put 1.03 to the x. Can somebody help me figure out what an appropriate window would be though?
It's like 17,000, I believe.
I think it's a lot more than that.
Or 70,000.
I did it was going to take a long time, so I said 100 years for x. X is years though, right? How many years you're going to have to leave that money in, and I wasn't sure, so I went out really far. This account is starting with 5,000 and this one with 5,200, so I went ahead and said, let's just start at $5,000. And then, honestly, the first time I graphed it, I didn't go up very high, and I got something like this. Okay. Yeah. So I ended up going all the way up to 100,000, and I still could not see where they intersected because they ran so close together. But you can use that intersect feature no matter what. So go ahead and graph it. You can't really tell what's going on because they're so close on top of each other. I could do it on my color one, and you might be able to see where they're a little bit better. But the bottom line is, all we want is the intersection. Okay, so the intersection is at about what year, guys? Can someone up front see that number? Yeah, 88.9 or about 89 years till they are the same. Which one do you think is going to be better before then?
The one it's more increasing. So probably
Guys, wait a minute. Think about this. Just look at the equations. Which one? The other one. Top one or the bottom one here? Okay, wouldn't getting an extra $200 to start off with be better? That's why it's taking so long for this account to grow, okay? Think about it. So if Brandy plans on leaving the money in the account for 30 years, which one should she choose? Obviously this second account, right? That's gonna start her out with 5,200. If it's 30 years, could we go to the table for 30 and look, I suppose, what the difference would be? Okay. At year 30, I really don't care what the difference is. I'd rather do another question, but we could scroll down to the table for 30 years and figure out. All right. She's got about, this is almost 12,300 and this is 12,006 plus. So there's over $300 difference in the two accounts at that point. The second one is much more, okay? Guys, what is E, by the way? What are you really multiplying here? Do that for me. What is E to the 0.03? E to the 0.03. 1, not exactly. 1.03 what? Okay, look at the difference. This was 1.03 and this is 1.0304 when you do e to the 0.03, okay? So they're extremely close. So that's why it took so long to overcome the fact that this one actually had $200 more in it. All right, I've killed that problem, backwards and forwards. This section, example 2, numbers 12 through 20, are there some of these you can't read? There's this one you can't I know this one you can't read. It's cut off on the worksheet. Okay, we can do that one together real fast. What would you do first?
minus 100.
Subtract 100. It's log base 4 of G, thank you. All right, then you would divide and get log base 4 of g equals what? 2. And then you would
What's the second big one?
rewrite it. Very good. So the answer is 16. All right. We were discussing this question 19 is kind of hard to read on your paper. Or 18, sorry. It's a problem. I did this problem and I was like, I'm really confused why they would even ask you this. I said, my understanding is that you can't have a base of 0, so I went back and found this page where they defined this. What does it say right here? Base b must be greater than 0 but cannot equal 1. So what are we going to write for an answer for this question? Not possible. Yeah, you can't do this. You can't. There is no value for j that will make this true, because you can't take a look.
What happens if you try to have
Base 1 and
Be-
calorie.
Okay, so the log base 1 of 7 equals what? So 1 to what power is going to become 7? Do you see why that could be a problem? That's a great question, though. Thank you. Yes.
Number 7, what's the number under the X?
A 3. It's 25 x over 3 to the x over 3 equals 5 to the x minus 4. Okay? Good question, Bryce. Anything else anybody can't read?
Number.
Otherwise, I'm going to
31.
go on and I think 20. Did you say 21?
No, I said
Oh,
30.
okay. I think 21 is not that hard. Can I just talk about it for 1 second so that you're sure you can read this all? Where do you think you're going to put in the 200?
To the H.
Find the displacement when the horsepower is 200. Okay? So we got to find D when H is 200. Now this question looks really horrible. And I lost the decimal.
So it wouldn't be like 1.003 to 200,
Yep. The class before got really confused by this. If you put parentheses in here, this mess is what we want to figure out later, right? So, like Sean said, can we just rewrite this? The base to the what? Equals, now log is gone and we just have this. So some calculator punching and multiplying and you should be good. Label is liters, the displacement in liters. Whoop. No, he's asking about a different question.
Oh, no, not 32, I'm 31.
All right, number, this section, even on my screen, it's hard to read. Let me see if I can make that any bigger. Ooh, pop. Things are popping out over here that aren't supposed to be showing because you weren't assigned those. Okay. Can you read it better now? These are all questions where you just want to do what? Because x is in the exponent.
Take the natural log or log of both sides.
Yep, you're going to have to take the log of both sides. Do your algebra, take the log of both sides, solve from there.
Unless it's
You know, when we talk about this, we talk about you can take the log, log, the common log of both sides, or the natural log of both sides. Do you get the same numbers as you work through the problems? No. At the end, you will come out with the same answer, but you don't get the same numbers, okay? The log, log of 2 and the natural log of 2 are not the same numbers, but as you work through the problem, at the end, it will come out the same because you've done something to both sides. It's like if I decide to square both sides or cube both sides, I'm going to get two different things to work with. But if at the end I undo it, it's going to be fine. All right. Can read those now? These two numbers 39 and 41 are just ugly. Oh, there we go again with showing problems that you aren't assigned. The these two are just the ones where you take the log of both sides and you deal with the decimals, the ugly decimals the whole way through. Do you know what I'm talking about? That's why it says round to the nearest hundredth. I did at least 3 places through the problem, and at the end I rounded to 2, but you should be fine either way.
We said 2 to the log of the 7.
Yes, so you're gonna have 2x plus 1, and then you're gonna have times the log of 7, whichever kind of log you wanna do. And over here, x plus 3 times the log of 3, and then you're just gonna have to make those ugly decimals and distribute them and all that junk. Does that make sense? Unfortunately,
Yeah.
that's supposed to be an x, kind of looks like a chicken scratch.
So when you put that out there, so how do you, like, what do you bring the log of 7 over to, like, log of 3? And
You
then you take
can,
x 3.
you're just gonna get ugly decimals and just distribute them and solve. Log of 7 times 2. You write down what ugly decimal that is. Yes, you can divide the log over here and you'll have less ugly decimals on one side, but you're still gonna have them. All right, what about these? Can you read these okay, guys? Remember on these, kind of check that your answer works.
Check with us.
Yeah, was there one that was hard to read, or? Everybody all right? Do we need to do any of those, or are you okay? 60, 62, 63. You want to save some time and energy? Think about something here. What is this? Is there any way for that to be a positive number?
No.
If you square something and multiply it by a negative, is it ever going to be positive? Nope. It could be 0, but can't take the log of 0 either, because that would be saying e to what power equals 0. Can't do that. So is this possible? You can combine all this and solve, and then if you plug your bank answers back in, it doesn't work anyway. So I'll save you some work on that one. What else? Can you read that one okay? I'm not sure we did any of these as examples. Any ideas on how to start these?
We cross out the logs of the sides.
Can you cross out the logs on both sides? That's a great question. No, because there's not one on this 3.
I think just needed one on each side.
No. If there's only one log equal to another log, then you can get rid of it. But this does not have that. It has that constant out there. You could actually rewrite 3 as a log base 2. I would just move this all over like Noah said. And then what, Noah? When you have 2 logs, how can you combine them? Okay, minus means divide, right guys? Did he get that right? Perfect. So if you cross multiply kind of thing, you'll get 8x over here, because 2 to the 3rd times x equals 2x minus 6. Do you get a negative answer?
Yeah.
Can you have a negative answer? You can't take the log of a negative number, so right there we need to write, if the only answer you get is negative, what do you write?
No.
Yeah, no solution or not possible or something. Caleb, are you writing these down?
Yeah.
Okay. You look like you're totally zoned out back there. All right, can I talk about this problem on acidity number 86? I had trouble with parts B and C. I was kind of confused. I actually did okay till then. Even the science didn't throw me off too bad. The acidity of a substance is determined by its concentration of hydrogen ions. Because the hydrogen ion concentration of substances can vary by several orders of magnitude, the logarithmic pH scale is used to indicate acidity. pH can be calculated by this formula. pH equals negative log of the hydrogen ion concentration. Now, they write it like this, but it doesn't mean like greatest integer function or anything crazy like that, okay? It's just the way they write that in science. Anybody know enough about this to know which end is acidic and which is basic?
Basic is one
Which of these seems more acidic,
juice.
baking soda or lemon juice? Okay, so this is acidic down here, and these are bases up here. What looks like it must be the middle? Yeah, water, okay. So the question says, determine the hydrogen ion concentration of baking soda. So we got to deal with this. So the pH is 8.3. I'm just going to call this X, okay? We need to figure out the X. What are we going to do first?
Divide by 9.
Yes, we need to make that negative 8.3 equals the log of X. Only then can we rewrite it as,
3 is equal to X.
okay? Type that in. You're probably going to get an answer in scientific notation. What'd you get, Noah?
5.012 times 10 to the
-9? Okay. Everybody okay? They got that on their calculator? They know how to get that? Can anybody read the question and figure out what the label is supposed to be for that? Right here it says, is the concentration in moles per liter? Is it MOL?
Yes.
Okay. See, I knew you guys would know. Okay. B says how many times as acidic is milk than human blood, okay? If I said this picture is 2 by 4 and this picture over here is 8 by 16, you would say, how many times as big is it?
4.
Okay, you took the bigger one divided by this one, right, to figure out how many times? So we need to do that with the hydrogen ion concentration. Can we figure out the pattern here, guys? Are they all just going to be 10 to the whatever?
Well, pretty much all.
To the negative whatever, right? So what do we need to divide by what? What did you do?
96.6
No, it's milk and blood, first of all.
10 to the negative
It's
Oh, wait,
10
that's-
to the negative,
6.6 divided by 10 to the negative 7.4.
okay, try that. And yes, you could subtract those exponents or move stuff around or just type it in your calculator, I don't care. It's about how many times? 6.3? Anybody else getting that? Okay, so milk is 6 times as acidic as blood. Good to know, huh? All right. This business about orders was a little bit confusing to me. The order of magnitude has to do with the powers. So by how many orders of magnitude is the hydrogen ion concentration of lemon juice greater than of ammonia? Really,
2.0 divided by
well, but it's how many powers of 10 differ? Well, these are all powers of 10. That's what these numbers are. So what's the difference here? 9. So it's 9 orders of magnitude. And I will not ask that on a test. That's a science question to me. Because I would not have been confident that I had that right until I looked in the answer book. This one I was very confident I had right because it says how many moles of hydrogen ion are there in 1,500 liters of human blood. So we take 7.4 and do what? Well, how many hydrogen ion concentration, what's the hydrogen ion concentration? We put it in here, 7.4 equals, so that becomes 10 to the negative 7.4. Okay, and that's how many moles per liter. So what are you going to do with that number to just get moles? Science people, if you have moles per liter, what are you going to do to get just moles? Multiply by liters. Thank you very much. So what do they tell us?
There's 1,500 liters and
So when we multiply those, the liter label will cancel. It's called dimensional analysis. At least, no, yeah, you're all shaking your head. So 10 to the negative 7.4 times 1,500 will give you the number of moles, whatever that answer is. All right. Everybody got down what they want? Not quite. Gunther, you need me to try to move it up higher? I could do extend page. Can you still see it, or? You all right? You good? All right, this question I want you to look at, please. Number 80. 80 and 81 are the same. 80 and 81 are the same concept. They want us to use an continuous exponential equation. This is, I think, the letters they use. Okay, this means some original amount became some new amount. And K is the rate that it's growing or decaying or whatever it's doing, and T is time. It says write a continuous exponential equation to model the number of stores as a function of the years of operation T, round K to the nearest hundredth. And what do they give us? Do they give us any of that stuff? Which things do they give us? Actually, that's after 8 years.
2 stores.
So 2 stores started out and became 206. What else do they tell us?
8 years.
The years is 8 years. So this is what we have. Can we solve that?
yeah.
What do we want to do? Good job. Take the natural log of that. ln of E is 1. So we're just going to divide this by 8. And if you read the question carefully, it says round K to the nearest hundredth. And you get what?
5, 8.
Does it round to 5/8, Elijah?
Yeah.
Okay. But this is not the answer actually, guys, because it says write an equation. So the equation is n equals the number of stores equals what times what to the what?
2 times E to the 0.582.
Did we do it right? It says number of stores n as a function of the year t. So they wanted us to have still a t in our equation, yes? Good job, Sean. And then for part B, you just put in a, what? 12. This is exactly what we're gonna do on Monday when we work on Newton's law of cooling. It's just that there's 4 numbers instead of 2 stores becoming 206. There's a extra number, well, there's 3 numbers. There's the temperature something is when you take it out of the microwave or something, and then the temperature of the air and the temperature you want it to be, and all kinds of fun. Did everyone pick up this packet? Okay, you need this packet. It's gonna be due Tuesday, not Monday, the homework check, okay? If you wanna get started on it this weekend, do the back page. Do the back page this week, if you have time. You know what you have to do. You got it? The rest of it we're gonna work on Monday, Tuesday.
We can keep this quiz, right?
Yeah.
Yes, you may keep the quiz.
I should have.
There might be a
That's
couple
going
more
on
I'm
the
gonna
fridge.
go over on this packet, I'm just trying to pass these out quick. Yeah.
Yeah, remember when you went to the store?
Got this? You guys got this? Brittany, did you get one? Yeah. Nisha, you got one? Yeah. All right. 80, shh, guys, settle down. 81 is the same kind of question. This one I think is a little hard to read. And part B was kind of tricky. This is 103. You know what? I kind of want to graph this because I thought I knew what it looked like and I was wrong. Actually, this is called a logistic graph. It means it's going to approach some number, and it depends on how many you start with, what it will finish at, whether it's going to go up or down. I thought it was going to go up, and I was wrong. Guess if I'd read the question, it may go up, but it goes back down. It's the number of people infected, so it would be really good if it went down at some point, right? Okay, can everybody read those numbers okay? It's 52.76, and then you need parentheses around the bottom, 1 plus 0.03 e to the 0.75 x. Okay, what's an appropriate window if this is number of people and time?
I'll try and use your pencil.
0 to 10 you want to go? Okay, we can always go out further if we need to. Does anybody remember anything about these equations last year? This is, listen to this question. Do you remember doing questions where you had like the number of fish in a lake approached a certain amount and then the environment would only support so many, so it started to level off? Okay, kind of remember those? That's the idea here, but I think this one doesn't actually grow the number of people, but it's this number on top that is usually the max, not always. So I'm going to try like 0 to 60 and see what happens. Okay, there's the number of people with this virus. So you're just going to put in t equals 5 or trace 5 and figure out how many people had this at 5 days. The second part, okay, the second part of the question says how many days will it take until there's only one person showing symptoms? If you do, or that's C, I'm sorry, if you do B, then C is pretty easy, but B was kind of painful, I thought. Did you try it? You copied the problem and then you got confused, or you got further than that?
No, it's basically, well, it's basically just what.
Okay.
we did this whole horrible problem and I kept thinking, it's gotta look better on my paper. I must have simplified something. And no, I didn't. I just left it messy.
Any ideas to start off how we're gonna get that t by itself?
That's fine.
Okay, so that's what I wrote down. I wrote p times that mess. By the way, can we add that and get 1.03e? Can we just make that 1.03e?
Oh, no,
Why not?
it's not the same.
Why not?
Wait,
If you have 1 plus 0.03x, is that the same as 1.03x? Why?
Why?
Order of operations say you have to do what?
Multiply first.
Multiply before you can add. Can't do that here either. Okay. Now what? We're trying to get t by itself.
Divided by
Divide by
p.
p. So I just said you can't do that, so that's what I write down.
good job.
Thank you.
And we could subtract 1.
Okay, then we need to subtract 1. Very good. Then we need to do what?
Divided by
Divide by 0.03. So now we have e to the 0.75t equals 52.76 over p minus 1 all over 0.03. And what do we need to do next?
the ln.
We need to take the log of both sides. Are we out of paper yet? 0.75t times the natural log of e equals the natural log of You don't want me to put this on the test?
Yes.
You have to divide the whole thing by 0.75.
I mean, with this problem,
that's the only
like,
problem?
sure. 2 plus 2 equals 4.
Okay, the last step is ln of e is 1, so we still need to divide by.
Oh my gosh.
Okay, so there's the answer. T equals.
What part is that, B or C?
This is part B. Part C is now into this equation. You're supposed to put 1.
So is that T
For
equals
P.
to L?
The natural log of, and it's only the log of the top. The bottom is separate. So put in a 1. See what you get. I want to know if you can type that in right or not. Put in a 1 for P. Think about it for a minute. What's 52.76 divided by 1? 52.76 minus 1 is 51.76. What do you got to do next? Okay, so 51.76 divided by 0.03. Now I have a crazy number. What do I do with that? ln of that crazy number, answer, and then I divide that by 0.75. Roughly 10 days, 9.9.
I don't know that hard work we get 10 days.
What are they gonna make?
Yes.
What does the ln actually stand for? I know it's natural log, but like,
It's the inverse of E. E is this magical number 2.718 or whatever it is. It's the inverse of that,
So 1 over.
not the reciprocal. What?
like what does like the L and the N stand for?
Natural log. I don't know why it's L and then N. It must be maybe French or something. You know how the pound symbol is LB because it's based on something else. Yep, yep. The logarithm natural or something, okay? That sounds like a naked tree, doesn't it? The logarithm natural.